Good day, children. Welcome to Sharda Math Classes. If you have not subscribed, please subscribe to my channel. I am going to bring more and more videos which is very useful for you. And also share this video with your friends so that they too will be benefited by these videos. Thank you. If you have any doubts, you can comment and you can ask your doubts. I will be there to clear all the time. Thank you very much. So in the last video, I had done exercise 1.3 and here last part of the lesson, real numbers. That is, what is the meaning of terminating decimal expansion and what do you mean by non-terminating decimal expansion. So first let us take up terminating decimal expansion. So what do you mean by that? Terminate. Terminate means it will stop. When you go on dividing a number by the other number, given number. Okay. So at one stage the division is going to stop. So such type of division we call it as terminating decimal expansion. Means at one point the division is going to stop. Means you will get the remainder as 0. So in such process we call it as terminating decimal expansion. So by seeing the rational number, how do you identify whether the given rational number is a terminating decimal expansion or a non-terminating decimal expansion? Now let us see. X is a number, rational number, which is in the form of P by Q. So X is equal to P by Q, be a rational number such that the prime factorization of the denominator. So when you take out the factors, prime factors for P and also for Q. What he is telling, the factorization of Q means the factors of denominator should be in the form of 2 to the power of n, 5 to the power of m, where m and n are positive integers. 2 can have any value, 5 also can have any value. So if the denominator has these two factors, 2 and 5, with different powers, whatever may be the power, where m and n are non-negative integers. Non-negative means the value should not be negative. Then we say x has a decimal expansion which terminates. Then we say that the given number x, rational number x, it has a decimal expansion which stops or terminates. So let us take up the example to check it out. Example 13 divided by 3125. So this is in the form of P by Q. Let me check whether Q which is nothing but your denominator, it has the factors 2 and 5. First let me find the factors for 13. 13 is a prime number, so it can be divisible only by 13. So 13 can be written as 13 ones are 3125. It is ending with 5, you can start with 5. 5 6 are 30. 5 2s are 10, 5 5s are 25. Again from 5 you have to divide. 5 1s are 5, 12, 5 2s are 12, 25, 5 5s are 25. Next, 5 2s are 10, 5 5s are 25. 5 5s are 25, 5 5s are 5 1s are. Okay, this can be written as 1, 2, 3, 4, 5. 5 to the power of 5. But according to the definition, what he is telling, according to definition, they have given that the factorization of Q should be in the form of 2 to the power of n and 5 to the power of n. If you write it in the form of 2 to the power of n into 5 to the power of m, we can say that the number x is a rational number whose decimal expansion is terminating. So how to write this? Here in the denominator, see you have only 5 to the power of m is there. So what I am going to do, I am going to take 2 power with the 2 number with the same power. Okay. I will take two number with the same power, 2 to the power of 5, 2 to the power of 5. So there is no change in the value. I am going to multiply two number with 5 power, both numerator and denominator, so that there will be no change in its value. Now this becomes 13 into 1 into 2 to the power of 5 divided by, this can be written as a into b whole to the power of n. This is in the form of a to the power of m into b to the power of n. So you can write a into b whole to the power of n. Okay. So it is nothing but 13 into 1 into 2 to the power of 5 means how much? What is the value of 2 to the power of 5? 2 into 2 into 2 into 2 into 2. It is nothing but your 32. So 32 and 5 into 2 is 10 to the power of 5. So when you multiply this, you will get 13 into 32 divided by 10 to the power of 5 means 1 followed by 5 zeros. So what is the number? 26, 2 carry 39, 41. 416 divided by 1 followed by 5 zeros. So this can be expressed in the form of decimal. So decimal will stop when you divide 416 by this, you will get 0.00416. Okay, so this can be easily divisible by 10,000. 416 can be divisible by this number and you will get the answer as 0.00416. Now the division stops. So this type of division you can identify just by seeing the rational number and finding the factors. You can easily tell whether it is a terminating decimal expansion or not. Okay, once again number is given. I have found out the factors for these two. 13 can be written as 13 ones are. This can be written as 5 to the power of 5. So here you have only 5, but I want 5 and 2 both. What I am going to do is 2 to the power of 5, 2 to the power of 5, both sides I am going to multiply so that there will be no change in the value. Okay. Now 13 ones are 13 into 2 to the power of 5 divided by these two different numbers but same powers. So you can write it as 5 2s are whole to the power of 5. This can again be written as 13 into 1 into 2 to the power of 5 is your 32. 2 multiplied 5 times 2 into 2 into 2 into 2 into 2. Okay, divided by 5 2s are 10, 10 to the power of 5. So now this can be written as 13 into 1 into 13. 32 into 1 into 13 you can multiply. So if you multiply, you will get the value 416 divided by 1 followed by 5 zeros. Okay, it is nothing but you make it 5 digits here. 5 digits, 0.00416. Now the decimal stops. So this is your final answer. So it can be expressed as a decimal expansion which is terminating. Terminating means the division stopped at this point. Second example, let us take one more example for this. 16 by 16,000. So 15 by 16,000. Now let us take the factors for numerator and denominator. 15 can be written as 3 5s are 1600. Find the factors for 1600. 2 8s are 800 times, 400 times, from 2 again 200 times, from 2 again 100 times, from 2 again 50 times, from 2 again 25 times, again from 5 5s are 25. Okay, this can be written as 2 how many times? 2, 3, 5. 1, 2, 3, 4, 5, 6 times. Can written as 2 to the power of 6 into 5 to the power of 2. Okay. So here, see, check the denominator whether it is in the form of 2 to the power of n into 5 to the power of m. Yes, it is in the form of 2 and 5. But see here, in order to make it easy, what I am going to do is, here the power of 2 is 6, whereas the power of 5 is here different, 2. So what I am going to do is, I am going to increase same as 2. Means here there is 2, I am going to take 4 more times 5. Means I am going to multiply both numerator and denominator by 5 to the power of 4 again. So that I will get 5 to the power of 6 here now. So this is nothing but 3 into 5 into 5 to the power of 4 divided by 2 to the power of 6 into, it can be written as 5 to the power of 6. Okay. Now this is nothing but 3 5s are 15. 15 into 5 to the power of 4. 5 to the power of 4 is nothing but 5 into 5 into 5 into 5. How much? 25. 25 is 625. Right? So it is 625 divided by 2 5s are whole to the power of 6. So here 15 into 625 divided by 2 5s are 10, 10 to the power of 6. So now what we can do? We can write this as, multiply 15 into 625, how much you will get? 15 into 6, 15 5s are 75. 7, 15 2s are 30, 37, 3 carry, 15 6 are 90, 97 divided by 10 followed by 6 zeros, 1 followed by 6 zeros. 4, 5, 6, 10 to the power of 6 is nothing but 1 followed by 6 zeros. Now here you have to make it 6 more digits. 4 digits are already given here. Add 2 more 0. That becomes your 6 digits. Now you keep the decimal point here. So this is your final answer. It is a decimal expansion of decimal expansion is terminating for the given rational number 15 by 1600. So once again what you have to do is, I am going to tell you once again, find the factors for 15, 3 and 5. For 1600 I have found the factors. It is 2 to the power of 6 into 5 square. So here, since the powers are not same here, if they are same, it will be easy for me to multiply. That is the reason what I am going to do. Only 2 5s are there. I will add 4 more 5s here. Means 5 to the power of 4. I am going to multiply both in numerator and denominator. So this becomes 3 into 5 into 5 to the power of 4 divided by 2 to the power of 6 into 5 to the power of 6. Now the powers are same. I can apply the rule a into b whole to the power of n. So 15 into 625 will be your numerator. Denominator 2 into 5 whole to the power of 6. So the product of these two is nothing but 9775, and the product of 10 to the power of 6 is 1 followed by 6 zeros. Now if you divide, you will get 0.0097775. So this is how you can identify whether the decimal expansion is terminating or not. Next, what is the meaning of non-terminating repeating decimal expansion? Non-terminating means the division will not stop. It will keep recurring or reoccurring. So, non-terminating repeating decimal expansion. Next problem. Let x is a rational number which is in the form of p by q be a rational number such that the prime factorization of q in the previous terminating decimal expansion, the value of factors of q would be 2 and 5 here, but here the factorization of q is not in the form of 2 and 5, where m and n are the non-negative integers. The powers of these two are non-negative numbers. It should be positive always. Then x has a decimal expansion which is non-terminating repeating, which is non-terminating and repeating, means it is a recurring decimal. Just by finding the factors you can find that they are non-terminating and repeating. So x is a rational number which is in the form of p by q, but the factors of q is not in the form of 2 and 5. Like in the previous case, like in the terminating decimal expansion, you had the factors 2 and 5 in the denominator, is it not? But here it is not in the form of 2 and 5. Let me check one example. Example 64 divided by 455. I am going to find the factors for this. So 64 can be written as 2 32s are, 2 16s are, 2 8s are, 2 4s are, 2 2s are. Simply you can write 2 to the power of 6. Okay. 455. From 5 you can divide. 5 9s are 45. 1. 7 1s are, 7 3s are 13. See here in the denominator you are getting different numbers. 5 into 7 square into 13. 7 you have 2 times here. Is it not? Sorry, 13 ones are this is. Okay. 13, 5 9s are 91 times, 13 times, 13 ones are. That means you have 3 factors, 5, 7 and 13. See here in the previous case, like how I did 2, only 2 is there, means I can multiply with 5 with different powers. It is not possible here. See in the denominator you don't have 2 at all. Therefore this type of rational numbers we can easily say that this is non-terminating. This type of rational number is non-terminating recurring. Okay. This type of rational number will be always non-terminating and recurring. Okay. Once again 64 by 455. 64 can be written as 2 to the power of 6. If you find the prime factors for 455, you will get 5 into 7 into 13. So here you have no 2 at all. You have different factors other than 2 and 5, 7, 13 and all. Just by seeing the denominator only you can come to conclusion that this is not non-terminating recurring decimal expansion. Second example let us consider for non-terminating repeating decimal expansion. 77, find out the factors for 77. Right. Okay. So the factors are 7 into 11. Factors are 7 into 11. So find the factors for 2, 10. 7 3s are 21. 30. 30 times. 3 10s are 2 5s are. So here apart from 2 and 5 you have other factors also like 7 and 3. Is it not? So according to definition, if it is having only 2 and 5, it is terminating. See here, along with 2 and 5, you have some other number also, means factors. Some other factors like 3 and 7. Therefore, this is non-terminating decimal expansion. This is non-terminating decimal expansion. So once again, second example 77 by 210. Find the factors for 77. It is 7 into 11. And then factors for 210 is as follows: 7 into 3 into 2 into 5. But here in the denominator you are not getting only 2 and 5, you are getting other factors also. Therefore, this is non-terminating decimal expansion. Just by seeing the factors only you can decide whether it is terminating decimal expansion or non-terminating repeating decimal expansions. So this is the end of the chapter real numbers. Thank you for watching my channel. If you have not subscribed, please subscribe so that it will be helpful to you, and please share my videos with your friends and do comment. Thank you very much.